April 24th, 2016. Guys, you're looking at the magnetopause. Notice the timestamp in the top left started on the 22nd. This is going to run up through the 23rd. Now, it's important because the research we've been doing for over a year now on what CERN is doing to our magnetosphere. The Earth shields, the magnetopause is combined inside that shield. Right there. And we'll go back and take a look at this. So we went into the 23rd. Notice your timestamp, 5:33. This thing's going in 4-minute increments as far as your frames. 5:37, it stops there, then it skips 2 hours. From 5:37 here, instead of 4-minute frames, they skip and go 2 hours. Now, you can't say that the information was actually taken down, guys, because this could have stopped information. This line is inside the satellites. Notice to the right it says the GOES 15, 14, and 13, and then the South Korean COMS satellite. They are inside that white circle band. They're actually showing them orbit. This collapsed inside that. That could have stopped information during that 2-hour period. Guys, there are other reactions on this planet that would have happened at that point, and any abnormalities that you have seen, let us know. Increased pressure, that would have thrown off navigation. It would have thrown off a lot of different things, communications temporarily, bird flight, whale travel, mammals and birds and fish that travel with the magnetic lines of force. But here, guys, they were way above 13.5 TeV, or way above 6.5 per beam. Notice that. At the right, that's 6,000, goes 65. That's in giga-electron volts, but when you take it to TeV, it's at 6.5. Now, this is a clipping meter. In other words, guys, if you've ever dealt with an oscilloscope or any other type of meter, you can adjust the clip, even on the soundboard. In other words, it will not go beyond that peak. It's called clipping on a power amp. Now, 0.45, that's very low power, and that represents the green beam right there. See that, guys, at 4.5, less than 0.5. Here's what happened, the luminosity. That is really what they're trying to achieve, and that's a measurement of what they're trying to achieve, is this light, not our light. And in this chart, guys, it does not go back to yesterday morning. It goes to about 1,800 hours at CERN time, which would have been about 1,600 hours UTC time. But they were spiking all day yesterday. Now, what they did, starting at just over 2,300 hours, is hit high peak luminosity. See that? It says Luma performance over the last 24 hours. And that's their goal. Last year, when they were starting to crank up, going into record territory at 13 tera-electron volts, they declared it the year of light. Again, not our light. They have dumped, you can see that, but they've rearmed both beams, 1 and 2, interlocked at 450 giga-electron volts. Again, when that goes up, you'll see everything rise, but that's 0.45 TeV. But yesterday, at the CMS page, notice this on the 23rd, in that time, again, they're 2 hours ahead of UTC time, they started to achieve luminosity for the first time this year in a solid line. The red line is delivered, the blue line is recorded. The trigger rate is the green dots, but that started to increase during the entire time, starting at 2,200 hours. That's the green section at the top. Now, there's a report and one news article about this. Are people starting to wake up? I hope so, but guys, this is way too dangerous. A couple weeks ago, when we started getting the solar flares from that large sunspot that came around, the earthquake started. Again, if we had had a major problem at that time as far as solar impact, we would have been in very, very deep trouble. Now, again, CERN at light means luminosity. It's a measurement of the number of collisions in an experiment. The higher the luminosity, the greater number of collisions. That's so you're seeing the increase in collisions. It says the high luminosity LHC program aims to extend the discovery potential of CERN's flagship. In this particular article, they called it a terrifying event. It said Earth's magnetosphere collapsed in space today for 2 hours. Trouble ahead for all of us. stunning and terrifying event has taken place in space surrounding our planet. For 2 hours a day, Earth's magnetosphere collapsed around the entire planet. The magnetosphere is what protects Earth from solar wind and some radiation. A lot of radiation. There's a lot of things that happen when that collapses, guys, and that's compression. When you compress the atmosphere, you put pressure on our Earth's earthquake fault zones, the tectonic plates. One of the things that has happened, National Buoy Center off the coast of New York, we've got a buoy generating wave heights of 180 feet. Guys, that's the only one doing it, but it is the outer warning system. This is where it drops off there near where it's the Hudson Canyon. You can see that. But there's Trenton, New York, Long Island, just above that. Now, if we look at the information that's coming from there, we see no other buoys. But again, this one could have happened right at that seamount. This could have been a compression effect. There were also reports of a large shooting star over that area, fireball. But this could have been a compression zone event and pushing down in this particular area. Water column height, it happened so fast. Let's look at the heights on it from 280, from 2580 in meters to 2640 plus. You see that? That's over 60 meters. That's over 180 feet. That peak could have been very close to 200-foot wave height. Now, wave height differences. Now, what that's saying is the trough would go up 100 feet, come back down to normal, drop another 100 feet. If you're at the bottom of that trough, you're looking at a 200-foot wave. You understand what I'm saying? Now, as it continues, this was just during that section. We saw 1, 2, 3 more peaks before it normalized back out. But this is the 15 seconds. Notice at the bottom of this chart, in 15 seconds, we had 3 peaks that went from trough to peak at close to 200 feet. Was it related to this atmospheric collapse because of the magnetosphere? Now let's go back to this image for a second, 537 UT. Everything's inside the satellite band. Both of the burnout lines, you see the red and yellow lines that are normally kept outside of that one's in, and then one even closer to our planet. See the inner line there? That's dangerous. Now, this is what happened at 521. This was just a few minutes before this event. Notice the red and yellow lines, that solar wave of energy coming in is well outside of the magnetopause. It's inside the magnetopause there. It collapsed so far. And this year of light that started last year, this time of light dealing with luminosity, is going to end up being very dangerous because they're about to change what they're colliding in the LHC. Guys, this is a heads up. We'll keep updates and we'll watch for reports of this event, and we need to watch them for further events like this. They're getting ready to crank it back up now as we speak. Look at the time, 5:37 UT. That's going to be very close to just after midnight on the East Coast. So the other side of the Earth would have been more Earth-facing at that time. We've had no major quakes, a couple of 5s in the area, but we didn't have any solar energy coming in either. But what we need to do is pay attention to the magnetosphere. That link is on our website at bpearthwatch.com. So is this magnetosphere link. So is the solar links, the satellite links, things like that would show us incoming. There was no incoming. This was a collapse from inside. What we did see was a jump in solar wind speed measured by the satellite from 400 to 600 kilometers per second. That is still going on, but that occurs when we have a geomagnetic sweep of what's called the heliosheath, and as it travels around the sun. But guys, we are at the point to where we've lost the big sunspot. It's went around the right edge of the sun. A couple smaller ones are starting to appear. But if you look at the stereo B images on the backside of the sun, starting on the 19th, you can see that there are sunspots forming on the backside. So this event, as far as solar activity, may have just begun a few weeks ago. Don't forget, one of the things we've been talking about is that CERN could be anticipating and helping to create the solar activity. We've seen when they were running hot, Solar filaments start to be pulled off the surface of the sun. Now we've got sunspot activity coming up and starting to increase. We see what happens with that with the earthquakes. But we talked about this. At these peaks, are they pulling energy into the super collider to create that high energy luminosity effect that we're seeing? Are we seeing a double impact as they pull in that energy to increase their collision power? It's a double effect. Magnetoshields are collapsing. Energy's being pulled downward. This would increase the Hall currents and the Peterson currents that I showed you a video of a few weeks ago. Check this image out. What you're seeing is the top of the magnetic field. This is in the North Pole. Now, this area where it's flat, the magnetic lines are not there as strongly as they are in other sections of our planet. It's almost open on the top and bottom if you've looked at diagrams of the entire magnetosphere, magnetopoles configuration there. You have incoming current. You see in the orange lines to the left on the inside, those are called field-aligned currents coming in and going back out. They hit the ground and they're called Peterson currents. Then the yellow circles are called the Hall currents that are created by the CERN is around on the other side of the globe at the between the 70 and 80 degree mark inside the second and third line, and they are directly connected to these Hall currents. So don't tell me that they can't affect it. They've built an underground coil that will interact with another coil, giving it a transformer effect, either step up or step down in transformers, if you understand that. But they say they can't affect it, but at the same time, they say their generated current is 100,000 times stronger than Earth's. So are they draining that energy to create luminosity, their light? We're watching. It's a heads up. Be safe.